In our last video, we introduced some symbols for an operational transconductance amplifier and a few basic ideas. In this video, we're going to look a little bit at the evolution of the OTA over the last 50 years and introduce the specific device upon which we will concentrate most of our efforts. As far as I know, the first commercially available integrated solid-state OTA was introduced in 1969, and this was designated the CA3080. This device went obsolete a few years ago. It's becoming quite difficult to find, and when you can find them, they tend to be a little bit pricey for what they are, and they do have some limitations that have been solved in more recent devices, which is of course why it went obsolete. The introduction of this device transformed the nature of designing voltage-controlled circuits, and specifically for my personal interest, it revolutionized voltage-controlled music synthesis. Of particular note, when Wendy Carlos used one of the early Moog synthesizers to create the revolutionary album Switched on Bach, which was wildly popular, and it was truly an eye-opening experience for people in the electronic music field. The machine which Carlos used to create Switched on Bach was done before the introduction of the CA3080, which means that all the voltage control had to be done either with bipolar transistors or field effect transistors, and that's a lot harder. One of the major limitations of the CA3080 and some of the other early OTAs was that you had to limit the differential input voltage to about 10 millivolts in order to maintain linearity. Now that's pretty small, and it can wreak havoc on your signal to noise ratio. Despite this, you can build some very useful circuits using the CA3080. It did not take long, however, after the introduction of the 3080 to improve upon that design, and a couple of chips of note were both dual OTAs. One was the CA3280, which had two OTAs in the package, and it also had a linearization scheme that used a couple of diodes to pre-warp the input signal so that you could extend that linear range from about 10 millivolts up to about 50 millivolts. Now, that's still a fairly small signal, but it's a lot better than 10 millivolts. The CA3280 is also now obsolete, and it never really achieved much product placement as far as I know. About the same time that the 3280 was introduced, a competing design, the LM13600, was introduced. This also was a dual OTA. It also had linearizing diodes, although that linearization was implemented a little bit differently than in the 3280. A few years later, the LM13600 was superseded by the LM13700, which is almost identical, but it did have a couple of improvements over the earlier design. This dual OTA is still widely used and shows no sign of becoming obsolete, so I could certainly recommend it for new designs. Today there are several OTAs available. Some are considerably more expensive than the LM13700, and that is one of the reasons we're going to focus on the 13700 is that it's cheap. In single unit quantity, you can probably buy one for about $2. That's $1 per OTA. And if you were going into manufacturing and you were going to buy in 1,000 quantity lots, you can probably get them for under $1 a piece, so 50 cents per OTA. The other reasons that I'm going to focus on the 13700 are A, it's very easy to use as such things go. It includes a pair of Darlington transistors on the chip to facilitate converting the output current to a voltage. That does have a possible disadvantage of introducing about a -1 volt offset in the output, but that in some cases is a little bit of a problem. In some cases it's not a problem at all. It just depends on the application. But that is something you need to be aware of if you're using the on-chip buffers. And the primary reason that I've chosen this one is that other than the CA3080, this is the OTA with which I have the most personal practical experience. In our next video, we will look at the inputs and outputs of the operational transconductance amplifier in a lot more detail. Until then.